Example for simultaneous equations with a quadratic. Here we have a linear equation, and under it we have an equation with degree 2. So in order to solve this system or these two equations, we need first to write y in terms of x. So y equals, you take the minus 2 to the other side, so you have 3 plus 2x, and then you take the value of y, which is in terms of x, and replace it in the second equation. So x squared plus, this is the place for the y, so you write y plus 2x squared equals 18. Now we expand. In order to expand this, we need to remember that we have the identity a plus b squared, and this is the same as 3 plus 2x squared. So first you square the first term, so squaring 3 is 9, plus 2 times the first times the second, so you multiply 2 times 3 times 2x, you get 12x, plus squaring the second, so squaring b would give you 4x squared, and this is what we got here. So we write it as x squared plus the expansion that we just did, and equals to 18. Now we take 18 to the other side so that we would have an equation equals to 0, and we would get 5x squared, because 1x squared plus 4x squared is 5x squared, plus 12 is alone, and then when you take the 18 to the other side, it would become 9 minus 18, and this would give me minus 9 equals to 0. Now when you reach this phase, you need to factorize in order for you to solve it. So this is a quadratic equation, and to solve a quadratic equation, one of the methods that you know is to factorize it. So you open brackets and you say that what are the two numbers that when you multiply them they give you 5, so it's 5 and 1, and x times x gives you x squared. Then what are the two numbers that when you multiply them they give you minus 9? It's minus 3 times plus 3. Now we are going to check if what we wrote is right, so you start expanding. 5 times 1, it's 5x squared, and then 3 minus 3 times plus 3 is minus 9. Now we need the one in the middle, so you check it by doing out times out. It's 8, it's 15x plus 15x, and n times n is minus 3x, so plus 15x minus 3x gives you plus 12x. So our factorization is right. Now if we didn't get this true, which is the middle one, then we have to exchange the 5 and the 1, or the 3 and the 3. Now how would we know if we're going to exchange them or not? This is called the trial and error method, especially or the sum and product method. Especially when a is not 1, you need to try a little bit harder. Now how to solve these two factors? You place the first factor, 5x minus 3 equals to 0, and then you say x is equals 3 over 5, or you place x plus 3 equals 0, and then x is equal to minus 3. So the two solutions are x equals minus 3 or x equals to 3 over 5. Now it's not enough to find the x, we need to find the y. So we take the values and replace them in this equation. So y equals to 3 plus, let me write it here, y equals to 3 plus 2 times minus 3. So y is equal to 3 minus 6, which is minus 3, or y equals to 3 plus 2 times 3 over 5. So y is equal to 3 plus 6 over 5, which is equal to 15 plus 6 over 5. So y is equal to 21 over 5. Now how do we write the solution? We write it as when x is minus 3, also y is minus 3, and when x is 3 over 5, y is 21 over 5. What do these solutions represent? They both satisfy the equations that we have in the beginning. So when you replace minus 3x and minus 3y in both equations, they will satisfy the equations. And when you replace 3 over 5 and 21 over 5 also in these two equations, they will satisfy it. Or you can say that these two are, if you're going to explain it graphically, these two solutions are the point of intersection between the circle whose equation is x squared plus y squared equals 18, the circle whose center is the origin 0, 0, and the line which represents which is represented by y equals 3 plus 2x. So in other words, the first equation represents the line, the second equation represents the circle of center O or origin 0, 0, and the radius is square root 18. And the points that we just found, the solutions that we just found, represent the points of intersection between the line and the circle.